So as I said in class, you're going to skip 21, 22, 23. And number 24, it says college entrance exam. So this is actually one that would be like on an SAT type test. In the figure below, if L and K are parallel lines, what is the value of X plus Y? So if X and 131 are a linear pair, they're going to equal 180. So 180 minus 131 equals X. So that's going to be 49. 180 plus 49 equals 180. 131 plus 49 equals 180. That means that Y is also 49, and they want X plus Y. So 49 plus 49 is 98. That would be your answer. For number 25, write the slope-intercept form of the equation. Now, in the review, most of these asked about writing slope-intercept form. On the test, I'm going to be asking you about point-slope form. So as I do these, I'm going to actually put them in point-slope and then convert it. So point-slope, remember, is y minus y1 equals slope x minus x1. Write the equation of the slope-intercept form. Right, the slope-intercept form passes through this point. So y minus -5 is plus 5 equals the slope, and we want it perpendicular to this. So if this is the slope of this line, perpendicular is the negative reciprocal, -3/2. X minus -2 is plus 2. Now we're going to go ahead and convert that into slope-intercept form for this question. Y plus 5 equals -3/2 X. -3 times 2 is -6/2. -6/2 is -3. So I'm going to change that to -3. And then I'm going to subtract 5. So y equals -3/2 X. -3 minus 5 is -8. Number 27. Find the value of X that would allow you to prove CD below is parallel to EF. So if CD, we're using Converse here, is parallel to EF, then 3x plus 3 is angle 1. Sorry, 3x plus 30 is angle 1. And the measure of angle 2 is 81. So that means that if these lines are parallel, then I'm going to call this angle 3 here, just for grins. And 3x plus 30 would be the same as angle 3 because these would be corresponding angles, and if they're congruent, then the lines are parallel. And this is 81. So if I add these all together, I should get 180. So because it is 10:49 back on the East Coast, but I am in Lake Tahoe and it's only 7:45, so we're going to use a calculator here. 30 plus 81 is 111, so 3x plus 111 equals 180. I'm going to subtract 111. So I have 180 minus 111 is 69. And that means that X is going to equal 23. For number 28, find the slope of the line passing through these points. So I'm going to do it the order you learned. Y2 minus y1, and that would be negative 7 minus negative 5 is plus 5. Negative 5 minus 6. Negative 7 plus 5 is negative 2. Negative 5 minus 6 is negative 11. Positive divided by a negative, or two negatives, make a positive. So the answer is 2/11. Number 29, write the equation in slope-intercept form of the line passing through this. So I'm going to start with point-slope form. Y minus y1, so minus negative 2 is plus 2, equals parallel. So I want a slope of negative 8, x minus 7. So y plus 2 equals negative 8 plus 56. So y equals 8x, subtract 2 from both sides, plus 54. Now, let's say they got really tricky, or I got really tricky, and I asked you to do this. I don't know why it's doing that. To do this in standard form, I would subtract the x from both sides. 8x plus y equals 54. But remember, I cannot have my leading coefficient negative, so I have to switch all the signs. 8x minus y equals negative 54. That's if I asked for it in standard form. That's if I asked for it in slope-intercept form. And if I asked for it in point slope, I'm going to reset this. In point slope, it was y plus 2 equals negative 8x, negative 8 parentheses x minus 7. We're going to do one more of these. Write an equation that is parallel to y equals 1/2 and passes through 0, 0. Well, actually right there, they've given you the y-intercept. If it's going through 0, 0, you should remember from past grade that it's going through the origin, that it's a proportional equation. So it has no y-intercept, so it's y equals 1/2 x. So write the converse of the true statement and decide whether the converse is true or false. So I'm going to type here a little bit. Set this a little smaller. If two lines are parallel, they never intersect. If two lines never intersect, then they are parallel. This is actually false because this doesn't indicate that they are in the same plane. Okay, if two lines are parallel, then from that we know they're in the same plane. But when you write the converse of two lines intersect and they are parallel, that's false because you don't say that they're in the plane. One could be kind of laying flat on a piece of paper. One could be coming through each other. So they don't intersect, but they're not parallel. In order for this to be true, it would have to say in a plane if two lines never intersect. But it does not. Hence, it's false. So for number 32, you're given that lines M and N are parallel. You're given that transversal T intersects M and N, and you're asked to prove that the measure of angle 1 is. So I'm going to type here. On this one, if I were giving you something like this on the test, obviously the measure of angle 1 is equal to the measure of angle 7 by alternate exterior angles congruence theorem. But it would actually say don't use alternate exterior angles theorem because that's what you're actually proving here. So measure of angle 1 is equal to measure of angle 3, which is equal to measure of angle 5. Measure of angle 5 is equal to measure of angle 7. Those are vertical angles. So that's the vertical angles congruence theorem. And 3 and 5 are alternate interior angles. I can't type, obviously. 1 and 5 are equal because they're corresponding angles. Now, 1 and 7, you would want to normally say, oh, well, that's alternate exterior angles theorem, but that's what we're proving. But what you start to see here is if that 1, the measure of 1 is equal to the measure of 3, and the measure of 3 is equal to 5, okay, and 5 is equal to 7, we have a whole bunch of things that are all equal to each other. So it's actually a big transitive property of equality problem, and that would be your answer. Now be aware on this problem, I don't really like it. Remember on the reviews, I just pull stuff from a test bank, and then for the actual test, I alter it a little bit. So on this one, what I don't like is that these theorems don't actually talk about the measures being equal. They talk about them being congruent. So if on a test or if on something else you would see congruent symbols, then you would be using transitive property of congruence. So just don't have that slip up on a test, because really that would be a more accurate proof. Number 33, write a 2-column proof. Given triangle ABC with AB is parallel to CD. So we're going to type here. And I don't have my triangle symbol, so I'm just going to write triangle ABC and AB parallel to CD. Got it all basically to fit. And that reason is given. Extend that out a little bit. Okay. Now, ABC, AB is parallel to CD, so I want to actually mark that. It might be marked there a little bit, but I want to mark it better. And you will have your papers to write up. So measure of angle 4 plus the measure of angle 5 is equal to ACD. That is the angle addition postulate. Okay. Now number 3 says the definition of a transversal. So I just need to prove this and this are both transversals. So I'm going to write AC intersects AB and CD. And I'm also going to write that BC intersects AB and CD. I can see it. I'm getting a little picky here because I'm going to talk about a transversal, then I want it to actually say transversal. A lot of problems we have don't involve this step, but if you got something that had this step, I want you to be able to do it. So now we have the measure of angle 1 is equal to ACD. So those are two parallel lines cut by a transversal, and they're congruent. Then those angles are congruent by alternate interior angles. Once again, I would feel better if it said they were congruent and then another step that they were equal, which would be definition of congruence, but that's not the way this proof did it. So they say now we can get right to our proving statement, which is measure of angle 1 is equal to measure of angle 4 plus measure angle 5. And I'll be honest. At this point, I'm not sure how that's working, but I'm just putting it in because it's the last thing, and that's what I want to prove. And they're saying that's by transitive property of equality. So let me make sure that works. We had 4 and 5 are equal to ACD. And then we had 1 is equal to ACD. So if 1 is equal to ACD and 4 and 5 is equal to ACD, then angle. I had this all typed out and I went through the whole thing, and then when I went to look back at the movie part, this one didn't record right. So we're just going to go through this. Write a 2-column proof to show that if given 2 is congruent to 4, then prove 1 is congruent to 3. Sorry, it says, should say congruent. 2 is congruent to 4 is the given. 2 and 4 are alternate interior angles, and that's the definition of alternate interior angles. So if alternate interior angles are created and are congruent, the lines that create them are parallel. That is the alternate interior angles converse. And it's the converse because you're proving that the lines are parallel. Then we went ahead and said AC intersects DC and AB, and BD intersects AB and DC. That's the definition of a transversal. So basically I have 2 parallel lines and they're cut in 2 different spaces by 2 different transversals. The transversal AC is the one that created the congruent angles 2 and 4. The transversal BD is the one that's going to create angles 1 and 3. And we can see there that 1 and 3 are alternate interior angles. So because we've proven that the lines are parallel, and we showed that 1 and 3 are alternate interior angles, angle 1 is congruent to angle 3 by the alternate interior angles congruence theorem. Problem number 35 is another proof. So we're told that M is parallel to N, and T is a transversal of M and N. So I want to go ahead and mark M parallel to N. Now, we're told next one is definition of a linear pair. We have a lot of linear pairs here. So we don't know which one they're talking about. So I'm going to look at step 3, and it says 2 and 3 are supplementary. Well, I can see that 2 and 3 are a linear pair. So I'm going to write angle 2 and angle 3 are linear pair. That should work, and that is a definition of a linear pair. So the fact now that they're a linear pair and they're supplementary, that is the linear pair postulate, okay, is that they're supplementary. And then supplementary means I hit the wrong button here. Scroll back up. There we go. So this was linear pair postulate. Measure of angle 2 plus the measure of angle 3 equals 180 degrees. That's the definition of supplementary. Now, angle 3 is congruent to angle 5. So let's look here. 3 and 5 are alternate interior angles. And we already said the lines are parallel, so this is alternate interior angles. And it's not the converse because we're proving that the angles are congruent. We are already told that the lines are parallel. So if we look at this first one, measure of angle 2 plus the measure of angle 3 equals 180. And instead of angle 3, we take out angle 3 and we just put in angle 5. That is substitution, and that's marked there. So if the measure of angle 2 plus the measure of angle 5 is 180, then they're supplementary. And that is the definition of supplementary. So that's problem number 35. Problem number 36. QS is perpendicular to PR. So if QS is perpendicular to PR, we can say that PTS is a right angle. I'm going to type here because we learned that two perpendicular lines intersect to form four right angles. And they want to prove that the measure of PTS is 90 degrees. So PTS is 90 degrees. That's what we're proving here. Angle PTS is 90 degrees because that's the definition of a right angle. 23, we are given that L is perpendicular to N and M is perpendicular to N, and we want to prove that angle 3 and angle 6 are supplementary. So with that given, if L and M are both perpendicular to the same line, they are parallel to each other. So because the lines perpendicular transversal theorem basically tell us is if two lines are perpendicular to the same transversal, they're parallel to each other. 1 and 3 are supplementary. I can see they're a linear pair, and a linear pair postulate tells us that a linear pair is supplementary. Now, what does supplementary mean? That means that their measures add up to 180 degrees. So the measure of angle 1 plus the measure of angle 3 is 180 degrees. Side note, 1 and 6 are alternate exterior angles and they're congruent because the lines are parallel. Definition of congruent angles means that the measure of angle 1 plus the measure of angle, means not plus, the measure of angle 1, so the measure of angle 1 is equal to the measure of angle 6. That's definition of congruence. So now, we had the measure of angle 1 plus the measure of angle 3 is 180. We're taking out this measure of angle 1 and we're just putting in the measure of angle 6. That's substitution. And then since they add up to 180 degrees, they're supplementary. That is the definition of supplementary. And that is what we were asked to prove.